Trig identities, algebra 2 trigonometry regions. There are two types of identities we're going to discuss in this video. The first are called the reciprocal identities, and we've talked a lot about these already. That's where cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. Sine can be expressed, tangent, excuse me, a tangent can be expressed as sine divided by cosine, and cotangent, which is the reciprocal of tangent, and then therefore can be expressed as cosine over sine. So we kind of talked about all of this already, but this is how we really need to start writing it. So whenever we see tangent in an identity problem, we rewrite it as sine over cosine. And whenever we see cotangent, we rewrite it as cos over sine. Whenever we see cosecant, we're going to rewrite it as 1 over sine. And whenever we see secant, we're going to rewrite it as 1 over cosine. Because what we're really attempting to do is rewrite everything in terms of sine and cosine, and then we could often simplify it from there. The next is called the Pythagorean identity, but I'm going to skip that for a minute and just do an example using just this information up here. So this first question says the expression tangent theta times cosecant theta is equivalent to what? Well, what I need to do is just always write tangent, cotangent, secant, cosecant in terms of sine and cosine. So I'm going to rewrite these to be functions of sine and cosine. So tangent theta I'm going to write as sine theta over cosine theta. And cosecant theta I'm going to write as 1 over sine theta. And then I know these are being multiplied because they're sandwiched together parentheses, and so I'm going to simplify. And just like we've simplified fractions in the past, like when we had x plus 2 here and an x plus 2 here, you could cross them out if they were the same. Same deal here. I could get rid of these signs. And what's left over is a 1 on top and a cos theta on the bottom. And that can't be simplified further, so which of these is equal to 1 over cos theta? Well, secant's the same thing as 1 over cos theta, so that is the answer, because 1 over cos theta equals secant theta. And that's really all we're doing here, is rewriting things in terms of sine and cosine and simplifying. Let's do another. This is a division of them. So first of all, let me write out the original. Cotangent x divided by cosecant x. Based on what I said on the previous page, we can rewrite cotangent to be cosine x over sine x. And that can be divided by cosecant. And cosecant, I could rewrite it as 1 divided by sine. And I'll keep that x there. Some problems will use x, some problems will use theta, some problems will use a, but you do want to write it each time. And when I have a fraction divided by a fraction, I change it to a multiplication of the reciprocal. So I'm going to, instead of 1 over sine x, it's sine x over 1. And that will get rid of that down there. Simplifying this, once again, I could cross out my signs, and I'm left with a cosine x on top over 1, and so it's just cosine x. So they're pretty easy. They're pretty quick a lot of times. As long as you remember what to rewrite things as. Remember tangent, right, as sine over cos, cotangent, cos over sine, secant, cosecant's 1 over sine, secant's 1 over cos. These problems can go really, really fast. Now, the other thing we're attaching to this lesson is what we call Pythagorean identities. And this is actually supposed to be over here. I think it is on your worksheet. It gets kind of squished together when it got put into this this file here. So I'm gonna move this real quick. I don't know. This might be a loud shutter. I'm not sure. Yeah, sorry if that kind of was too loud for you. I apologize. But anyways, I'm going to put this, because this really belongs over here. And then I'm going to cover this guy up over here. So just bear with me 1 second, because I don't want you to confuse these two things. Okay, so what we have over here, this is the Pythagorean identity. This is the most important piece. That's sine squared theta plus cosine squared theta equals 1. And let me give you a brief explanation as to why this works. It really comes from the Pythagorean theorem. Like if we had a triangle with angle theta in there, we know that this is the opposite side, this is the hypotenuse, and this is the adjacent side. If I were to do the Pythagorean theorem, a squared plus b squared equals c squared with these, it would really be a squared plus o squared equals h squared, right? So that would be a squared plus o squared equals h squared. And then what I could do is I could divide everything by h squared. Say I want it to be equal to 1. Well, if I divide anything by itself, this becomes 1. So I'm going to divide this by h squared. I'm going to divide this by h squared. And what I get here is this can be written as a over h whole thing being squared, because the top and the bottom are both being squared, and plus o over h squared equals 1. And what this really is a over h, adjacent over hypotenuse, that is cosine, and opposite over hypotenuse, that is sine. So it's in a slightly different order here, but we know with the plus sign between them, it doesn't matter which one comes first or second, right? 1 plus 5 equals 5 plus 1, so that doesn't really matter. But this is where it is. This is your sine squared plus cosine squared equals 1. So that's why this does work, because it's basically just playing with the Pythagorean theorem. But this is an important thing to really memorize. This comes up a lot in identity problems, or at least a version of it. One of these equivalent expressions that I have listed over here. Like if I were to minus cos squared to the other side, I would have 1 minus cos squared equals sine squared. And if I were to, take this original and minus sine squared to the other side, I'd end up with 1 minus sine squared equals cosine squared theta. So these two over here are just versions of this one moved around. But if you could take a second and try to commit this to memory, I think you already know this stuff up here. You should. These are maybe a little new and unfamiliar, so take a second now and just remember sine squared plus cos squared equals 1. And then if I have 1 minus sine squared, I'm going to change it to cos squared. If I have 1 minus cos squared, I'm going to change it to sine squared. If I have sine squared plus cos squared, I'm going to change it to 1. And so we'll see some of these problems like this and this, but you'll see that stuff come up. Like in this last example I'm going to do for you here today. So sine squared x plus cos squared x, that is equivalent to 1 over sine x is sine x. And 1 over sine x is the same thing as cosecant x. There's your answer. So these problems really are pretty quick, just using these rules from here. So I don't expect we'll have a whole lot of trouble with these. Make sure you change them and simplify where you can. If you end up with a fraction divided by a fraction, you could change it to multiply by the reciprocal, and so on. So take some time to memorize these rules up here, and this can actually be a pretty easy topic for us. All right, that's it. Practice tomorrow.